In section 6.7, we'll be performing similarity transformations. Remember, we've talked about transformations before. We've looked at reflections, rotations, and translations. Remember, a reflection is when we reflect a figure across a line, like a mirror. A rotation is when we rotate a figure about a point. And a translation is when we slide a figure. What we're going to talk about today, though, is a dilation. A dilation is either enlarging or reducing a figure to create a similar figure. The coordinate notation we get for a dilation is that x comma y maps to k times x comma k times y. We multiply each part of the coordinate by the number k. And then one thing you do need to note is that we usually use the origin as the center of dilation. This makes our dilations as easy as possible. We'll only ever use the origin as the center of dilation in this class. In future math courses, if you look at dilations again, you might use a different point as the center of dilation. But for here, it's just the origin, and that actually makes things very simple. This number k, though, that we multiply by is called the scale factor of dilation. If k is going to be greater than 1, we're going to get an enlargement. For example, we can have k be 2, which will give us a triangle that will have sides twice as long as its originals. If k is between 0 and 1, though, say k was 1/2, we're going to get a figure that has sides half as long as the original, which is a reduction. Let's look at an example. We want to draw a dilation of quadrilateral ABCD that has vertices A at 2, 1. We have A at 2, 1, B at 4, 1, C at 4, -1, and D at 1, 1, or 1, -1. There's our 4 coordinates, and that creates quadrilateral ABCD. We want to use a scale factor of 2, k equals 2, and the origin as the center of dilation. This is all good. This means that every ordered pair we need to multiply both coordinates by 2. A, which is 2, 1, becomes 4, 2. And we'll label that A prime. A prime is 4, 2. B, which was 4, 1, now becomes 8, 2. B prime is 8, 2. C is now 8, -2. We'll label that C prime. D prime is 2, -2. And that gives us this new figure in blue, which is quadrilateral A prime, B prime, C prime, D prime. What we do see is that A, B, C, D is similar to A prime, B prime, C prime, D prime. If you want the coordinate notation, we took all our ordered pairs x, y and mapped them to 2x, 2y. This is the coordinate notation for the dilation on your screen.